Okay, question 4, slightly more involved question now. Two forces acting on a particle, so best thing is to read it through for a minute just to get your head around what's going on. And we move on to 4a, which is trying to find the angle between r and the vector j. R is the resultant of the two forces. We don't know what r is at the moment, but we do know it's parallel to I minus 2j. So, draw a decent sized diagram. I, j, and it's parallel to I minus 2j. And it's parallel to, so r itself heads off in that direction. Again, we don't know where it is at the moment. Right, we want the angle between r and the j, vector j, which is the j axis basically, so it's that angle there, theta, which is what we're looking for. So we can start off by finding this angle here, which is alpha. Okay, so tan alpha equals minus 2 over 1, which equals minus 2. Put that into the calculator. Alpha equals minus 63.43. For the purposes of what we're trying to do, it's actually a plus, so the actual angle, the magnitude is 63.43. So the answer, the angle we're after, theta, equals this angle between the axes, which is 90 degrees plus 63.43 degrees, which comes out as 153.4 degrees to 1 dp. For part B, I've got to show that 2p plus q plus 3 equals 0, and looking at the initial information, p and q are the I and j components of one of the forces. So to do this question, I'm going to equate out the forces acting on the particle. So what have I got? I've got 4i minus 5j plus pi plus qj, they're the two forces, and they equal to a resultant which is parallel to I minus 2j. Now I don't know the value of the resultant, but if it's parallel to I minus 2j, then I can represent it as lambda times I minus 2j. So I'm going to equate out the I values, and I get 4 plus p equals lambda. That's equation 1. Now I'm going to equate out the j's, and I've got minus 5 plus q equals minus 2 lambda, and that's equation 2. Okay, my answer I want in terms of p and q, so I need to eliminate lambda, so I'm going to take equation 1 and I'm going to times it by 2, which gives me 8 plus 2p equals 2 lambda. And we'll call that equation 3. Equation 2 plus equation 3 gives me 3 plus 2p plus q, and that equals 0. And I can rearrange that now to have 2p plus q plus 3 equals 0, which is where I want to be. Question 4c is worth 7 marks, so there's probably going to be a little bit of thinking to do there. So looking at the question, I've been given that q equals 1, and we're looking at acceleration. So, following on from B, if I know that Q equals 1, I can work out the value of P. Once I know the value of P, I know the second force that's acting on particle P. Combine that with the other force and I get the resultant force, and again using F equals ma I can find out the value of m from that. Okay, so we have got Q equals 1. We've shown in part B that 2p plus Q plus 3 equals 0. So 2p plus 1 plus 3 equals 0. I can equate all that lot out to get p equals minus 2. Okay, so that now means that the second force acting on there, I know both p and q, so I can get resultant force equals 4i minus 5j plus, and I know that p is minus 2, so that's minus 2i plus, and we've said that q is 1, so that's going to be plus j. I can now add those two forces up, and I get 2i minus 4j. And that is my resultant force. Right, in the question then, it tells me the magnitude of the acceleration, so I'm actually only really interested in the magnitude of the resultant force. Magnitude of r equals square root of 2 squared plus 4 squared, using Pythagoras, and that is root 20. Finally, using Newton's second law, F equals ma. I now know that F, which is the resultant force, root 20, and that equals mass times the acceleration, and the acceleration they have told me is 8 root 5. Divide through by 8 root 5, m equals 0.25 kilograms.